Hello there, and this is Mr. Frazier. Welcome to Geometry Flipping the Classroom. And today we're going to be talking about 5-6, which is part 1 and part 2. All right, so part 1 of 5-6 deals with something called inequalities in one triangle. All right, now it is a comparison inequality, and we're only dealing with one triangle. So it's understanding a relationship between sides and angles. And we've talked about this in class several times. Okay? When you have an isosceles triangle, that means two of the sides are equal. And the isosceles triangle rule is that if your sides are congruent, then the angles across from those sides are also congruent. Okay. Now we're going to learn about something that is kind of like a common sense type thing. Okay. And it's that if they're not equal, then their relationship uh, is related. So I'll clarify that another way. We'll start with one that we know, exterior angle theorem. We know that the exterior angle is equal to the remote interior angles. That means if we add these two together, they will add up to equal the exterior angle. Well, now we know a corollary to that as well, which means neither one of these angles are bigger than this angle. These angles must be smaller. Some of you are like, well, duh, you can't add two things together to equal something bigger and then say that these could be bigger because you add them together, they got to equal this. Right. So it is a common sense type thing. It's understanding that your exterior angle is always bigger than your remote interior angles. So we're going to put some numbers here. And the numbers they use are like 1 and 2 and 3. So that means angle 3 is always greater than, notice the greater than symbol. Okay, angle 3 is greater than angle 1. Angle 3 is greater than angle 2. So understanding how these angles are related to each other. That 3 is bigger than 1 and 3 is bigger than 2. Why do we know that? Because what we learned is that the two remote interior, that means the ones away from the exterior angle, and remember the exterior angle must be an extension of a side. Okay, just because there's an angle out here doesn't mean it's exterior. It's because it's an extension of one of the sides of the triangle. Okay, that's what makes it an exterior angle. And yes, you have to remember your arrows for an exterior angle. All right, that one's easy. Okay, usually not an issue with figuring out that particular rule. Okay, it's the ones that follow, or being able to put it together in a type of problem. So let's say I draw a lot more complex picture. Okay. And then we do 3, 4, 1, 2, 5. All right. So now if I look at that picture, what should jump out at me? And I'm hoping most of you by this time are saying, oh, the congruency marks, right? Because if you're not recognizing the congruency marks as giving you information, that's where we're going to have an issue, is the fact that you believe the congruency marks are just pretty, okay? You have to know that the congruency marks are leading you to different answers. So for example, the congruency marks in this picture tell me that these two sides are the same, which means the angles across from those sides are the same, which means this angle and this angle are the same. 1 and 2 are equal to each other. Well, why might that be important? We'll talk about that later. Okay, so it's important that you understand why the congruency marks would be there. Then it's secondly important to dissect this picture. Why? Because you have 1, 2, 3 triangles. Small one, big one. And each one of them has different exterior angles. And that's the tricky part. See, 1 is an exterior angle to this top picture. There's 3, there's 4, and 1 is an extension of a side. See how I tore that apart? I just kind of took it, dragged it over. All right. See, 1 is an exterior angle to this triangle, not to the whole thing, but to this one. Now, don't get confused because 5 is not an exterior angle to this triangle. Notice, 5 is not an extension of any of these sides. Okay, so here are my 3 sides. 5 goes out like that. 5 is not an exterior angle. Okay, so it's important to understand what's exterior angles and what's not. 5 is not an exterior angle. 5 is an exterior angle to the bottom picture. 5 is exterior here. Notice, you can see I separated the picture. See how that comes apart? Slid 1 down, slid 1 over. These are the things that you have to be able to do. Okay, so 5 is an exterior angle to 3 and 1. Okay, so the secret to this isn't necessarily being able to see it. You have to be able to pull it apart and take it down to its basic components. Okay, you want to try and get it to look like this because then this is a lot easier. It's a lot easier to say, oh, 3 is bigger than 1 and 3 is bigger than 2. In this question now, you know 1 is bigger than 3 and 1 is bigger than 4 and 5 is bigger than 3 and 5 is bigger than 1. Okay, why? Because of the rule we just talked about. Now, actually, 5's bigger than 1, and then of course over here is C, and we'll put some labels in here. You got C, A, B, and D. So you can go, oh, this is triangle A, B, D, and this is triangle B, D, C. Now this is important only because you must determine the relationship between the exterior angle and the remote interior. Now, why do I know angle 5 is bigger than both 1 and 3? Hopefully you look at this picture and go, oh, see, I didn't forget about these congruency marks, which means I can add congruency marks here. Since I already know this isn't a remote interior angle, how do I know it's still bigger? Because the rule says that 5 is bigger than both this angle here and this angle here. Well, these two angles are equal because these two sides are equal. So if 5 is bigger than 1, 5 also must be bigger than 3. Why? Because those two are the same measurement, because it's an isosceles triangle. So now you see the car wreck we're running into. All the vocab is melting together. And you have to add congruency marks to pictures, understand what things are called. These are called remote interior angles. This is called an exterior angle. Okay? And it's going to be hard to disseminate or pull it apart from one picture. That's why I pull it apart into 2. Remember, an exterior angle must be an extension of one of the sides of the triangle. It just can't randomly be outside. All right, so now you tell me, why is angle 5 greater than the measure of angle C? Why would those be? Why is angle 5 greater than angle C? Hopefully you're able to tell me in class. That'd be one of the questions I'm looking for. Okay? All right. And then we move on to the second thing. Now this becomes something that is relatively common sense again. If equal sides are across from equal angles, then unequal sides are across from unequal angles. Okay? I know that sounds weird. Okay, and that the size of the angles tells you the size of the sides, not the measure of the size, but their comparison. So for example, I'm going to draw a triangle like this. Okay. I'm going to tell you this one is 60 degrees. This one is 80 degrees. And who could tell me what the last one would be then? The last one would be, correct, 40 degrees. How'd you get that? 60 and 80 is 140, and 40 more makes 180. Correct. Now, this is the relationship we're talking about. If you can tell me which angles are bigger, you can then tell me which sides are bigger. If you can tell me which sides are bigger, you can tell me which angles are bigger. They're related to each other. How? How, Mr. Fraser? Okay. We don't go by looking at the size. You don't go, oh, well, that side looks bigger. No. We go by the numbers. Angle B is the smallest angle, which means AC is the smallest side because it's across from the smallest angle. 60 is the second smallest angle, which means the next size would be AB. Now these are in order from smallest to largest. Sometimes they'll say from largest to smallest. Sometimes they'll say find the biggest. Sometimes they'll say find the smallest. Sometimes they'll say put them in order. And then it doesn't matter which order you pick as long as you pick one. But the idea is the questions change. This concept never does. So you just have to read carefully when they ask you, hey, what kind of triangle am I looking for? Or how do they want me to order them? And then, of course, 80 is the biggest angle, and it's across from BC. Okay. Now you can do everything in reverse. Well, what do you mean reverse? Well, reverse would be, let me draw a triangle. Now remember, it doesn't have to be to scale. I'm going to put this triangle as E, F, G. And now I'm going to say this is 2, this is 5, and this is 10. Who wants to give me the biggest angle in that triangle? Don't give me the biggest side. Give me the biggest angle. Correct. We go hippy skippy across from 10, and its angle E is the biggest angle. Okay, and you do the other two. Put them in order of biggest to smallest. And again, I will check that being problem 2. Excuse me, in your notes. If you just write what I'm drawing and there's no words on my picture, you have to fill in the words. Being an effective note taker, you can pause this video, rewind it. Lots of cool things you can do. All right, go back, watch it twice. That's what I would suggest. Some kids watch it once, don't draw anything, or just draw all the pictures, and then the second time they fill in all the words. All right, so being able to understand going forwards and going backwards. Bigger sides across from bigger angles, smaller angles across from smaller sides. Okay, these are all the relationships in which they have. Being able to plug in the missing numbers, all triangles add up to what? Correct. All right, so now I'm going to give you a third problem, and you're going to do it all by yourself. Many of you should have noticed that these are coming right from the book. But if you hadn't read the book, even though you're supposed to read the book, then you are going to be missing out on the information as well. It says that in the figure to the right, and in this case to our left, but in our figure, the measure of angle S is 24 degrees. The measure of angle O is 130 degrees. Okay. And which side of triangle SOX is the shortest? And tell me why. Which side is the shortest? Okay. And then again, we'll go over this answer. You'll do the work, and I will check your answer when we come back, when we're in class. Now make sure you're not only telling me how you did it. In other words, show me the math, fill it all in. Then you have to write an explanation, which means a sentence. Okay, so you do math to find the math answer and then sentences. All right. Now we're going to move on to 6-2. Okay, or 6-2. 5-6, part 2. Okay, and part 2 deals with the triangle inequality rule. Okay, and there's usually 2 questions that they ask you in this part. In this section, the 2 questions revolve around are these the sides of a triangle? In other words, the question will say, can these be the sides of a triangle? That's what it will say. It's the question. Is this a triangle? Can this be a triangle? Are these the sides of the triangle? Which one of these can be the sides of a triangle? All right, and we're going to learn about what has to happen. It's called the triangle inequality theorem. Again, it's telling you something about triangles. When you have a triangle, 2 of the sides, when added together, must always be bigger than the 3rd side. Not equal to, but bigger than. So if I were to give you a list of sides, say 4, 5, and 7, and said, can that be a triangle? You would have to add the 2 sides together to make sure that they are bigger than the 3rd. Now in your book, they show you add these 2, then add these 2, then add these 2. I'm letting you know the only one you have to check are the 2 smallest. If you add the 2 smallest together, they must always be bigger than that 3rd side. If they're not, then this cannot be a triangle. Well, in this case, 4 and 5 is 9. 9 is greater than 7. So yes, this could be a triangle. So the first question, can this be a triangle? Are these numbers a triangle? Can this be a real triangle? Could this be the sides of a triangle? That's how they ask you these questions, okay? And you have to understand that 2 of the sides must add to be greater than the 3rd side, all right? The other question they're going to ask is, what could the 3rd side be? So they're going to give you 2 sides, and they're saying, what do you think the 3rd side is? I'm going to show you the shortcut, okay? But there is a longer version. I'd rather you know how to do it. Okay, so understanding that you're supposed to add 2 of the sides every time to be bigger than the 3rd. So in theory, what they wanted you to do is do 4 plus 5, 5 plus 7, and 4 plus 7. And for each one of those answers, that has to be bigger than the 3rd. So that 4 plus 5 has to be bigger than 7. 5 plus 7 has to be bigger than 4. Duh. 4 plus 7 has to be bigger than 5. Duh. When one of the numbers is already bigger, when you add the other one, it's going to be. So that's why I say the 2 smallest are the ones you're really looking for. Right. So understand that 2 sides must be bigger than the 3rd. They write out 3 problems. It's okay if you don't. I'm letting you know that you could just check the 2 smallest and it'll work. So let me give you a problem. Can that be a triangle? Can those sides be a triangle? Okay, have your answer. Then the next one would be this one. can these three be a triangle? And then the third one I'm going to give you is this. Can those three be a triangle? Okay. So hopefully I see the math. I will tell you that this answer is no. Hopefully you're able to tell me why. This answer is yes. And the one that I want you to struggle with, that you should be able to do, is this one. Is that a triangle? All right. So now we're going to talk about finding the possible sides of a triangle. Okay, so I'm going to move that up a little bit. So the second type question is, hey, what could the third side be? The math is no different. You're supposed to add two of the sides, and they're always supposed to be bigger than the third. So let's say they give you two sides, 5 and 16. Here are two sides of a triangle. What could be the possible third side? All right. So the long version of this would be writing out the math problems. When would you have to write out the math problems? When you have equations. So for example, if they gave you this side was x plus 2 and they gave you this side was x plus 7, well, now you're going to have some math problems. This is something the honors do. This is something we do. Okay? So if I need to know what the third side is, that means if I added these two together, the third side's got to be bigger than that. And that's what they're wanting you to do. Well, let's make the third side x. So they're wanting you to do 5 plus x is greater than 16. X plus 16 is greater than 5. And 16 plus 5 is greater than x. So those are the three problems they want you to write out. Why? Because these two must be greater than the third. So if the third one I don't know, whenever I don't know something, I put an x. So it'd be 5 plus x is greater than 16. 16 plus x is greater than 5. And then 5 plus 16 is greater than x. All right. Here's the short and skinny. That means here's what we can do as a shortcut. Hopefully you're paying attention. If they ask you what is the third side, you only need to do two problems. Add these, subtract these. Add 16 and 5, I get what? Correct, 21. Subtract 16 and 5 and I get what? 11. Which means my answer must be bigger than 11 and smaller than 21. Because when I add 16 and 5, I get 21. So that means that answer must be smaller than 21. 21's got to be biggest. Because x has to be smaller than when I add these two together. 21. When I subtract them, which would be this problem here, x has to be bigger than 11. This problem becomes null and void because when you solve it, you get a negative number. You'd end up with x is greater than negative 11, which does not exist. All right, so rather than set up the three problems, I'm more interested in, can you add these two numbers? can you subtract those two numbers? Understanding that if I need the third side, it has to be between the addition and the subtraction of these two numbers. And the third side must be bigger than 11 and smaller than 21. It's got to be in between. Cannot be 11, cannot be 21. It has to be in between. All right, making sure we're able to find the number in between. Okay. And that is the triangle inequality rule. That's part 2. So part 2 consists of, is this a triangle? Can those numbers make a triangle? So you add the two smallest, and it's got to be bigger than the third. Then it's a triangle. If you add the two numbers and it's equal to the third, no triangle. Add the two numbers and they're smaller than the third, no triangle. Add the two numbers, it has to be bigger than the third. I say do the two smallest. If that works, you're done. Okay. And then the next question is, what could be the third side? So that means you don't have a third side. It means you add the two numbers together, you subtract the two numbers, and the answer you're looking for could be in between those two. Remember, when they say what could be the third side, there's multiple answers. Okay. You need to try and narrow it down in between. And that's the triangle inequality rule. All right. Hopefully you worked well. You had a good weekend. And we'll see you on Monday doing our work. Remember, test is Friday. Say bye, Nico.